This is a review of material we've already done. I'm gonna try to go a little slower, but still keep it in a shortened time frame. Okay, use the diagram to the right to name the following. 4 colinear points. So it's asking for 4 points that are on the same line. Well, this only has 3 points. This only has 3 points. 1, 2, 3, 4. So that's the one we're looking for. So we're just going to go in a row. H, N, K, I. H, N, K, I. 4 colinear points. Remember, colinear just means on the same line. Okay? On same line. Okay? Name a line that contains point M. Now, for this, there are many different answers. You can give P. You can give MO with the line symbol. MN with the line symbol. NO with the line symbol. Okay? Those all have MI. Okay? So, anything that represents this line. A line that contains points H and K. Alright? So again, there are multiple answers to this question. A line that contains points H and K, the easiest one is HK. Now, we can do HN, HI, NK, NI, KI, any of those, but the easiest one is the one they give us, H and K. Alright, D, another name for line Q. Well, Q is right here, so another name for it, well, there's JK, but we can do JL, KL, and you can reverse the letters, KJ, LK, and it doesn't matter. It's just got to be points that are on that line. Now the intersections of line P and R. Now intersection is just where they cross. Okay, well they cross right there at K. Nope, sorry, that's my fault. It's P and R. P is up here, R is here, so they cross there at N. Okay? So, that's all that is. It's nice, simple, and you're just reading the diagram. Now, for the next section, we're using a diagram still. A line containing point F. Well, F is right here. Again, we have multiple options. We can do EF, DF, DE, or we could simply call it J, because that's what it's called right there. Any one of those is fine. You don't need to list all of them. Any one of those is simply the answer. Now for part B, another name for line K. Now this time we can't use K because that's what it gives us. So BE. BC would work. EC would work. Okay? Anything containing 2 of those 3 points. Okay? A plane containing point A. Well, the simplest answer is right there, the fancy written letter. M. Now, you don't have to try to write it fancy, just do that. If you want to get, more clever with it, then DEF. Because that contains point A. But the easiest answer is that plane right there. It's already named for you. Now, an example of 3 non-collinear points. Well, BEC is collinear. DEF is collinear. So as long as you don't pick those 3 or those 3, you're good. Basically, if it has A in it, you're good. So A and any other 2 points. So A, B, E. If you pick 1 point from this line and 1 point from this line, you're good. So DEB or BED, whatever. Yes, that's an A. Look like a triangle to me. And the intersection of plane M and line K, well, plane M is the shape, and line K is this line here. So where does this line cross with the shape? And that's point E. And so we're done with that section. Now, for section 3. Use the diagram to the right to name the following. 3 coplanar points. Sorry for the noise, some people are walking by. 3 coplanar points. So 3 points on the plane. Well, you've got 1, 2, 3, 4 points to choose from. Any of those 3 points will work. So WXY. You could choose VXW, VYX, and any of those 4 points. Basically, the only one you can't use is Z. Now, R is not a point. It's the name of the plane. So that's why we can't choose R. Z is above the plane. It's not inside that shape. So that's why we can't use that. Now, a plane containing point X. Now, there are several different possible answers to this question. The easiest is R. But the reason I say there's several possible answers to this triangle here forms a plane. And so WXZ is a plane. And so that would work as a plane. WXYV forms this square here as a plane. And so that could work. But R is the simplest plane that it is a part of. Now, the intersection of plane R and ZVY. Well, ZVY is this triangle here. ZVY is this triangle. And it wants to know the intersection of this triangle and this plane. Well, it crosses at this line segment, because this line segment is on that plane. So it is VY. And so we would put VY, because that entire line segment is on the plane. So it's not just the 2 points, that entire connection of VY is there. So we need the line segment symbol. Now, this one again is an interesting question. How many planes appear in the figure? Well, we have plane R, so that's 1. This pyramid has a triangle, because it has a triangle on this side, a triangle in the front, a triangle in the back, and a triangle over here. So that's 4 triangles. It has a square on the bottom. So it has those four and the plane R, so 4, 5, 6 planes. And then how many of those planes contain point W? Well, point W is part of plane R. It's a part of this triangle. It's part of this triangle, and it's a part of the square. So one triangle, a second triangle, and the square, so that's 3, and it's part of plane R, so it's a part of 4 planes. Okay? So you have to look at the entire thing, not just this. I know we didn't do a whole lot of looking at the entirety in class, we just looked at simple ones like up here. But we will have to look at some of these. Okay, and in this last section, use the diagram to name the following. The intersection of lines L and M. Well, again, line L is here, line M is here, they cross at E. Another name for plane Q. Well, Q is here, so we've got G, E, F, and I. So, I, F, E. Okay, that are all in the same plane. You could have done F, E, G, you could have done all 4. Alright. Are points D and E colinear or coplanar? D and E. Well, are they on the same plane? Well, D's in this shape and E's in this shape. So they can't be coplanar. Are they connected? Yes, they're connected. So they're colinear. How many times do plane P and Q intersect? Well, do these two shapes touch at all? The answer is no, so it's 0. And that's everything on points, lines, and planes.